In this video, I'm just going to be going over the very basic hydrolysis of nitrile groups with acid, and then in a future video, I'll do the hydrolysis of nitrile groups with base. It's a long mechanism, so I thought I'd just get right into it. So, starting with some just basic generic nitrile group, I'm going to draw um, something like this. I'll draw my nitrogen in green, why not? From here, hydrolysis means the breaking of bonds with water, and we're doing it with acid, so acidic water is where that ties in. So H3O plus is our go-to. And at this point, you notice that nitrogen has that lone pair of electrons on it, that lone pair of electrons, and it can readily accept that extra proton that hydronium has. And so it will go ahead and do that, just like that, and we get to this intermediate, where now nitrogen has that extra hydrogen, and so we need to give it a positive charge. So at this point, recognizing what's in solution is helpful, and what we have is a bunch of water. Right? It's a hydrolysis reaction. We just took off a proton from hydronium, which helps increase the amount of water in solution anymore. So there's our water. Our water is going to see something that's partially positive. Nitrile groups are already have that carbon that is partially positive, but when you attach that extra proton to nitrogen, you make them even more electrophilic. And so we see the oxygen of water attacking that carbon, and then nitrogen gets its electrons back. So let's draw what we have now. Just like this. And nitrogen also has that electron or that proton up there. So to happen next, we've attached water. We should recognize from here on that we are in an aqueous solution. And so because we're in an aqueous solution, we can go ahead and keep doing things with water. This becomes especially more evident when we see what has to happen if we introduce water into the equation. Water is going to pull that proton off and regenerate our acidic environment. So anytime you can do that, regenerating your environment, that's usually going to be a favorable thing. So we now have this intermediate with nitrogen still with two bonds to it. It has that extra proton, and then we have an alcohol group. In order to do that, we used water to pull off that proton we used water to pull off that proton from the oxygen, so we've regenerated our acid, and so we have more H3O plus. So what is the best base now in solution? Well, it's going to be nitrogen. Nitrogen versus oxygen. Nitrogen is usually going to be more basic, and so we're going to let those electrons on nitrogen pull off that proton. And we can now draw our next of many intermediates. And nitrogen. And now it's two protons, and we need to give nitrogen a plus charge. Okay, so what can we do next? We've